In this video, we're going to show how to set up a blaze grating in the RCWT calculator. I assume that you've already opened the RCWT calculator and it's already set up to a similar measurement or calculation as what we had before, where we're starting with a wavelength of 650 nanometers and going from 0 to 50 degrees with an increment of ½ degree, and we're changing the angle of incidence as our variable parameter, looking at the reflected in the transmission diffraction efficiency, and psi is 0, so it's not conical, and psi is 0, so it's p polarization in this calculation. So we go into RCWT settings, and I'm going to increase the number of orders a little bit to provide some more stability because it's a more complicated calculation. Base period, I'm going to change a little bit larger than we had last time. This is now 5 microns, and again it's going to be fused silica incident medium and air in the transmission. The layers are set up. This is actually set up for a in the previous calculations, so we're going to change the height and add multiple layers. So what height do we use? We're going to be setting up a approximation for a blaze grating with 4 layers. So this is the kind of thing that we're going to be doing. And there's 4 layers there. So the height would be, of each layer, would be 1/4 of the total height that we would need for one wavelength of OPD between the highest and the lowest part of the blaze. Remember, we're working in transmission. And then the location is also divided out into fourths along the base period. So what height do we need? Let's go to the workspace, to the command window here, and let's see here. Oops. So the height that we need would be the wavelength 650 e minus 9th divided by n minus 1, and it's 1.4. 1.4608 minus 1. Now that's for one wave of OPD, but if we want 1/4 of a wave OPD, then each layer would be 352.6 nanometers. So we'll just copy that right in there to the height. And now the duty cycle here describes the start transition points of the material, and we're choosing our material to be the same as the substrate, the glass. And so this first guy should have an air index that's medium 2 at 1/4 of the period. So if we look at what that is, it's like this. So that's the base, the first layer there, which starts at 1/4 of the 5 micron period, and then the next layer would start at half, or 2.5 here, so this would be 1.25, this will be 2.5 microns, and then the next one over here at 3/4, and then here's the fused silica incident medium. And right now this is showing as red. That's actually in there. These two should be the same color. Okay, so that's the first layer. So we can copy that layer, and then we can paste it down here by hitting the paste last. And now it's the same thickness, but we just need to change this offset. So that offset would be 0.5 for this layer, and then we can again paste another layer here at the bottom, and then that would be 0.75. Okay, so if we preview that, then that's our 4-step approximation, and you kind of have to flip it over, but basically that's what we're doing here to the blaze grating. Okay, and so now we come back to here, and we calculate our diffraction efficiency, and it takes a minute. And this is P. Oh yeah, okay, so I wanted to show you here a couple of things. Move this out of the way. First we'll look at the result. So there's the transmitted efficiency, and the ideal efficiency would have been about 81%. It's a little bit lower than that in reality, and then it changes dramatically as you go beyond about 15 degrees. Efficiency starts dropping off quite a bit for P-polarization, and then the reflected distribution comes up quite a bit as you increase the angle of incidence greatly. So what's happening back here is you're getting a couple of error messages, and this is just right at the end of the calculation for those very large angles, and you're getting an ill-conditioned matrix warning. So probably at the very end of the calculation, when we're talking about out in here, it may not be as accurate as you'd like it to be. Right in here would be fine. In order to get rid of this, you can increase the number of orders in the calculation. Let me show you where that is. Increase this number. It just takes longer to calculate. So I just wanted to show you what that looks like. All right, that's it.